Hi there. In this video, we are going to have a look at trigonometric functions. Before we look at them in more detail, just a reminder about how a function operates. We have a function which is some kind of rule, which takes a set of values called the domain as inputs, often an x value. The rule processes the x value, the input, and outputs a value, which we often call y, which belongs to a set of numbers which we call the range. So we've got x as the input, y as the output, the function is the rule. And our notation for that is f of x equals y. F, the function rule, takes an input x and outputs a value called y. And I guess my point here is that sine, cosine, and tangent basically do operate like functions. The input, the domain, is the angle. So the sine of 0 or the sine of 3 pi on 2. The domain is really any number we want it to be, because we could have the sine of 17 pi on 12, or the sine of a billion pi, or even just a radian measure of 1 still works as an input. And the output will always give us a number. So we have an input, we have sine, cosine, and tangent, as we've talked about on the unit circle, and then the output is just this value, this ratio. So what I'm going to do next is show you what that looks like using Desmos. Because if they're functions, then these functions can be graphed. What does the graph look like? Remember that a graph really is a picture of the function. It's a graphical representation of the function. And that's really handy for us because when we look at a picture, it tells us a lot about how that function behaves. We're going to have a look at the base sine and cosine graphs in this video. In the second video in this series, I'm going to have a look at transformations of the sine and cosine graph. And then finally, I'm going to look at the tangent graph, which does behave differently. What you can see here is I've got the unit circle. We've got a measurement of 1 here, then 2, then 3, then 4 along the y-axis. So we can see that the unit circle is of length 1. And we're going to have a look at what the angle does in the unit circle and how that corresponds to the sine, cosine, and tan graph. Let's focus on sine. I'll run it through first just by pressing play, and then we'll come back and explain what it looks like. Here we go. That's to 2 pi, 360 degrees. And away it goes again. You can see that it's repeating exactly the same form between 2 pi and 4 pi. And away it goes from the start. We'll rewind that. It's a beautiful shape, the sine shape. It's got a name, a sinusoidal shape. Let's have a look at how that's being described by the function. Let's have a look at the first quadrant. The first quadrant is between 0 and pi on 2. We know that when the angle is equal to 0, then the sine of the angle is also equal to 0, and hence the graph starts at the origin. If I now zoom it up to pi on 2, let's have a look at what's happening. The value of the function is increasing, the output is increasing, until we get to pi on 2. I'll just approximately get it to the right spot here. And we can see that at pi on 2, the function outputs 1 because the sine of pi on 2 is equal to 1. And then we have all these values in between. In the first quadrant, sine is positive, and hence all our values, our output values, are going to be positive as well. Between pi on 2 and pi, we are in the second quadrant. But the value of sine is decreasing as it approaches pi. So in the second quadrant, we see this graph. The value output getting smaller and smaller, but because of the nature of how the function works, like with the reference angle, we can see that it's basically a mirror image here to a mirror image there. So it's the same picture here, but reflected that way. And that gets us through 1/2 of our unit circle, from 0 to pi. The third quadrant sine is negative. So therefore, we're going to start dipping underneath the x-axis where the output, the y, is negative also. So I'll slide that. And again, because of the way sine is defined, and cosine and tan, by the reference angle, we can see that this is really a reflection of this. It's just turned upside down, and there it is there. And that makes sense too. And then finally from 0 to back to 2 pi, we've now completed one revolution of the circle, and we have finally the graph still negative, but slowly eking towards 0. Once we get to 2 pi, we've done a full rotation. So it does make sense that from this point, we are going to continue to get the same shape until we get to 4 pi. And we're done. Of course, I just deliberately chose from 0 to 4 pi, but I could keep on going and it would continue to have this sinusoidal wave repeating over and over again. Similarly, I could have gone backwards and I would have had this graph continued backwards as well. So we have this shape here going on and on forever in a cyclical fashion. And in fact, sine, cosine, and tan are not usually called trigonometric graphs, they're called circular graphs or circular functions because they are based on this idea of being cyclical, repeating after a certain period. And we'll talk about more about that in a subsequent video. So that's sine. Let's have a look at tan. I'll go a little bit faster through tan because it effectively is the same idea, but of course, cosine values are a little bit different. I'll rewind and let you see it draw out. Now, if you're thinking this has a very similar shape to sine, you wouldn't be wrong. This is in fact the same sinusoidal wave, but of course, it's starting off from a different spot. So let's have a look at that. The cosine of 0, if you remember, is 1. And so if the input is 0, the output of the function is 1. And that's why the graph starts up here. Then, as I go down, I have in the first quadrant, I have my cosine output as being positive, but by the time it gets to pi on 2, we've hit 0. And that makes sense too, because when we have the cosine of pi on 2, 90 degrees, we have no direction, no movement in the x direction on our unit circle, and hence the value of cosine pi on 2 is 0. So we have this lovely turning down here. And again, this shape is then repeated 4 times over, but just positively or negatively, depending on what quadrant. So this quadrant here is the second quadrant where sine is positive and cosine is negative. So hopefully, unsurprisingly, we have the same shape but upside down all the way to pi, 180 degrees. Next, we have between pi and 3 pi on 2, we have cosine negative here as well. But now it's climbing back up to 0 until we get to 3 pi on 2, at which point it is 0. And then we finally finish with going to 2 pi, where by the time it gets back to the x-axis, so 2 pi here, you can see the rotation around here, we've got the cosine being 1 once more. And then for the next rotation, it's just repeating. First quadrant, second quadrant, third quadrant, and fourth quadrant, and we're finished. So cosine is a cyclical or a circular function as well. It has a cycle that starts at 1 and finishes at 1, and then that repeats. It kind of looks like a tulip or something like that, that sort of cups or a cup of some description. Okay, so that's what the sine and cosine graph looks like. The sine and cosine graph is in your information booklet. So you do have reference to it in your information booklet, but it's also good to just know that this is what the shape is supposed to be, so that you can apply transformations to the sine and cosine graph to create different graphs.